In this video, we're going over course schedule. So there are a total of num courses you have to take, labeled from 0 to num courses -1. You were given a very prerequisites where the prerequisites at index I is go to A and B. So indicate you may take course B first if you want to take course A. For example, the pair 0 and 1 indicates that to take course 0, you must take course 1 first. So return true if we can finish all of the courses, otherwise return false. At first example, we're given num courses is go to 2 and this prerequisite, and we can take all the courses because we can take course 0 and then we take course 1. This is a way of taking a total of 2 courses, so we return true. Let's go over the dot process. So we will be implementing topological sort. So each of the courses can be treated as a node inside a graph. So if we currently have the prerequisites X and Y and Z. So if we have to first take Y before we can take X, we can draw an edge from Y to X. And then in our second one, we have to take course Z before we can take course Y. So we can draw an edge from Z to Y. Then the current graph will be Z to Y to X. Now based on our current graph, we can see that we must take course Z first. And why can we take course Z? Because there are no incoming edges. So the integrity of node Z is equal to 0. If the integrity of a node is equal to 0, this means there are no prerequisites. And if there are no prerequisites, we can take the course. Now, this means we can process all of the nodes with an integrity of 0 first, and then eventually remove the integers from the other nodes. So let's go over the pseudocode. So we're going to create a custom class node. So there will be the following fields. The first one is ID, the course of the ID, and also neighbors, neighboring nodes, and also integrity. Number of incoming edges. Now we're going to have a constructor. Constructor for the node is going to pass in ID. So we initialize the field ID and then initialize neighbors list. Now we can start solving the problem. First, we're going to create an array. Nodes to keep track of all of the nodes, or courses in this case. Then we're going to iterate through from 0 to num courses -1, denoted as ID. So we're going to set node's ID to a new node with ID. Then we're going to iterate through the prerequisites, or the input array. So denoted as pre. Now we want to take pre1 before we take pre0. So we want to add pre0 to the neighbors of nodes pre1. Actually, we need to retrieve the node. So we need to retrieve the nodes of pre0 and then add it to the neighbors of nodes pre1. This is essentially creating an edge between pre1 and pre0. Now we want to increment the integrity of nodes pre0, because we have created an edge between pre1 and pre0, so we want to increment the integrity of the node at pre0. Now we want to process all of the nodes. So we're going to create a queue to process all of the nodes. Now we want to start processing the nodes with an integrity of 0 first, because if the integrity is equal to 0, there are no prerequisites, This means we can take the course. And when iterate through the indices of nodes, denoted as ID. If nodes at the current node .integrity is equal to 0, this means we can take the course. So when we add ID to queue, we're also going to create a variable courses to keep track of the number of courses we have taken. Now we want to process the queue. So while queue is not empty, we want to pull an ID from queue. We want to increment the number of courses we have just taken. Now we want to iterate through the neighbors of ID or nodes ID, denoted as neighbor. This is the node, the neighboring node. Now we want to remove the integrity associated with this neighbor, because we have taken the current course, which is the ID of the current course. If we have taken the current course, for example, if we are taking Z, we want to remove or decrement the number of integrity associated with node Y here. So we want to remove this edge. And then this will allow us to take course Y. Now we want to decrement integrity of nodes neighbor.id.integrity. Then if nodes.id.integrity is equal to 0, this means we can take the course now. Want to add neighbor.id to queue. Now we want to return true if courses is equal to num courses. Else return false. Now let's go over the time and space complexity. For the time complexity, we get O of n plus e, and then plus O of n. Where ne are the number of nodes and edges. So n plus e, we're going to create the nodes array. And then O of n is processing all of the nodes or courses. Now let's go over the space complexity. For the space complexity, we get O of n plus e plus O of n. So we get O of n plus e. This is our nodes array. And then we have our queue. Now let's go over the code. So we're first going to create an array, our private custom class first. And then we're going to have our ID, the course ID. We're going to have a list of neighbors. And then we also have the number of integrity, initially 0. And then we're going to create a constructor, pass in the ID of the course. And initialize our neighbors array. Then we're going to create our nodes array using the num courses and the prerequisites. We're going to iterate through the indices to initialize all of our course IDs, or initialize all of the nodes in this case. Now we're going to iterate through the prerequisites to create the edges between our nodes. We want to create a director edge from pre-1 to pre-0. then we can increment the integrity at pre-0. Then we can return the nodes. Now we want to process all of the nodes. We're going to create a cube. Then we're going to create a variable courses to keep track of the number of courses we have taken. Then we're going to iterate through the nodes and retrieve the nodes with integrity of 0. If the integrity is equal to 0, this means there are no prerequisites, and if there are no prerequisites, we can take the course. Now we want to process the cube. We want to pull an ID from the queue, increment the number of courses we have taken because we have taken the current course with this ID. Now we want to iterate through the neighbors of the current node. And they want to decrement, because after we have taken the current course, we want to decrement the integrity of its neighbors. Now, if the integrity of the neighbor is equal to 0, this means there are no more prerequisites for the current course. This means we can take the course. Then we can return true if courses, the total number of courses we have taken, is equal to the total number of courses available. Let me know if any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview.